Welcome aboard. Our new student, your learning journey starts now. Large language models are undeniably reshaping software development. We're seeing specialized tools like CodeLlama, GPT-4, and Code Whisperer becoming integral parts of our workflows. Their ability to generate code from plain text is genuinely impressive, promising productivity boosts and potentially lowering the barrier to entry for new developers. Benchmarks like Human Evil confirm the rapid improvement in these models. But here's the catch. While LLMs are great at churning out initial code snippets, maybe a few hundred lines, they hit a wall when dealing with larger, more complex systems. As codebases grow, the magic starts to fade. We see performance drop, code quality degrade, think increased complexity, lower maintainability, and more bugs. It's like trying to explain a complex concept to someone who keeps forgetting the previous points. The core issue is scalability. LLMs struggle to maintain context and coherence across vast, intricate code structures. So, what's the root cause? Two big factors: the context window and inherent quality issues. LLMs have a limited memory span, the context window. Even with large models boasting 200K tokens, hitting 100K can still cause performance dips. For a large project, this means you're often forced to manually cherry-pick relevant code snippets, feeding the LLM only a partial view. It's like trying to understand a story by reading only one chapter at a time. This leads to the LLM forgetting crucial parts, resulting in inconsistent outputs and logical errors. Beyond context, the code itself is often messy, inefficient, hard to maintain, full of errors. These small flaws compound dramatically as the codebase grows, creating a mountain of technical debt. It's a classic conflict. LLMs optimize locally for the next word, but large systems need global coherence. Refactoring is our attempt to impose that structure. This brings us to the core idea. Can we use established software engineering practices to tame the LLM beast? Specifically, we're looking at principles like separation of concerns, single responsibility principle, and domain-driven design. The hypothesis is simple. By breaking down the code into smaller, well-defined, conceptually coherent pieces, we can make the LLM's job easier. It's about building a scaffold for the LLM to work within. We expect this structure to help maintain context, improve code quality, and ultimately make LLMs more effective in large-scale development. Let's start with the basics: separation of concerns and the single responsibility principle. SOC is about dividing the system into distinct, independent modules, each tackling a specific part of the problem. SRP is the follow-up. Each module should have only one reason to change, meaning it has a single, well-defined responsibility. Think of it as organizing your toolbox. Instead of one giant, messy box, you have separate containers for wrenches, screwdrivers, etc. For LLMs, this means smaller, more focused code units that fit better within their limited context window and are easier to understand. It's about clarity and focus. Now, for more complex systems, especially those tied to intricate business domains, domain-driven design offers a more sophisticated approach. DDD has strategic and tactical layers. Strategically, it uses bounded contexts. Think of them as distinct business areas or subsystems. Each has its own clear boundaries and consistent language. This allows different parts of the system to evolve independently. Context maps visualize these relationships. Tactically, DDD uses concepts like aggregates, groups of related entities treated as one for data consistency, and repositories to abstract data access. DDD is powerful for managing complexity in large, business-driven systems, emphasizing clear boundaries and alignment with business needs. So, how does this refactoring actually help the LLM? First, it's about better context management. By structuring the code into smaller, semantically coherent units, we naturally fit more relevant information within the LLM's limited context window. It's like giving the LLM a focused, well-organized document instead of a sprawling, chaotic manuscript. This reduces the cognitive load, allowing the LLM to focus on the task without getting lost in irrelevant details. It leads to higher fidelity output, less context damage, and makes it easier to manage dependencies between modules. It's about making the information digestible. Second, it's about improving semantic clarity. When code has clear responsibilities and boundaries, like SRP and DDD enforce, the purpose of each segment is much more obvious. This enhanced clarity makes it easier for the LLM to understand the code's meaning and intent. It's not just about syntax, it's about semantics. This understanding translates into the LLM generating more consistent and relevant additions or modifications. Compare asking an LLM to modify a monolithic application manager class versus a user service class with a single, clear responsibility or operating within a well-defined ordering bounded context. The latter provides much stronger context, leading to a better internal understanding of the code and ultimately higher quality and correctness in the generated code. Third, refactoring enables targeted interventions. Instead of dumping a massive unstructured codebase into the LLM, we can guide it to work on specific modules, classes, or bounded contexts. The prompts become much more focused, just the code unit needing change, its immediate dependencies, and the desired modification. This drastically reduces noise and ambiguity. It's like asking a doctor to examine a specific symptom, not the whole body at once. This focused approach makes the LLM's changes more accurate, localized, and respectful of the existing architecture. It gives us more control over the LLM's actions. Fourth, there's the idea of implicit prompts. Well-refactored code, with its consistent structure, clear naming conventions, and defined boundaries, acts as a subtle guide. LLMs trained on vast amounts of code, including well-structured examples, learn to recognize these patterns. It's like navigating a city with clear streets and landmarks. Even if the LLM doesn't get explicit instructions about the architecture in every single prompt, the underlying structure of the code itself influences its predictions, nudging it towards generating code that fits naturally into the existing framework. It's a form of passive architectural guidance. Fifth, and perhaps most practically, refactoring improves error containment. The modularity and clear boundaries inherent in SOC, SRP, and DDD act as firewalls. If an error occurs in a well-defined module or bounded context, it's less likely to spread and cause cascading failures throughout the entire system. It's like having modular rooms in a house. If one leaks, the damage is contained. This isolation makes debugging and fixing issues much simpler compared to the nightmare of spaghetti code or a big ball of mud. It's about limiting the impact of mistakes. Now, let's compare SOC, SRP, and DDD. SOC SRP focuses on the basic organization of code within modules or classes, primarily managing local context. DDD, on the other hand, is a higher-level strategy centered around business domains and the overall structure of the system. It provides context maps to visualize relationships between bounded contexts. For large, complex systems, especially those with significant business logic, combining DDD for strategic division and SOC, SRP for tactical implementation within those divisions is often the most effective approach. DDD often uses SOC, SRP within its own constructs. They are complementary tools, not mutually exclusive. Of course, this isn't a silver bullet. There are challenges. Refactoring takes time and effort, potentially negating the initial speed advantage of LLMs. LLMs themselves still struggle to perfectly grasp and follow complex architectural rules. Maintaining the structure requires ongoing effort. We need better tools to assist with this LLM-assisted refactoring and validate the results. Prompt engineering is crucial. And ultimately, human oversight is essential for guidance, validation, and ensuring the architecture stays sound. It's a multi-pronged approach: better LLMs, smarter tools, careful prompts, and diligent human supervision. In conclusion, LLMs are powerful tools, but scaling them effectively requires addressing their inherent limitations, particularly with large code bases. Applying established software principles like SOC, SRP, and DDD offers a promising path forward. By structuring the code, we enhance context management, improve semantic clarity, enable targeted interventions, leverage implicit prompts, and contain errors. While challenges remain, integrating these refactoring techniques into our LLM workflows is key to unlocking the full potential of these tools for building truly scalable, maintainable, and reliable software systems.